we are going to construct the state model of a mechanical system. So this is the given mechanical system. Here you are having two mass M1 and M2. A force is applied to the mass M1, and due to this applied force, a displacement is occurred in the mass M1 is Y1, and displacement occurred in the mass M2 is Y2. Okay, the element V1 is connected between M1 and M2, and the element K1 is connected between M1 and M2, and this element K2 is, or the spring K2 is connected between the fixed support and M2, and this dashpot V2 is connected between the fixed support and M2. First we are going to consider the mass M1. So when considering the mass M1, the differential equation is M1 into d square y1 by dt square plus this dashpot is connected between M1 and M2. So V1 into d by dt of y1 minus y2 plus this spring, it is connected between M1 and M2. So K1 into y1 minus y2 and is equal to the applied force. Here you are applying a force in the mass M1, so it is equal to F of t. So we have written the differential equation for this mass M1. Now we are going to write the differential equation for this M2. So M2 into d square y2 by dt square plus K2 into y2 b2 into dy2 by dt plus v1 into d by dt of y2 minus y1. When writing M2, you have to consider y2 first. So y2 minus y1 plus k into y2 minus y1 is equal to 0. So now we have written the differential equation governing this mechanical system, mechanical translational system. Now we are going to choose the state variables. The state variable is nothing but x1 equal to y1, x2 is equal to y2, x3 is equal to dy1 by dt, and x4 is equal to dy2 by dt. These four are the state variables, and f of t, the applied force, is nothing but the input. Okay. So now we have taken now we have taken the state variables. What are the state variables? x1 is equal to y1, x2 is equal to y2, x3 is equal to dy1 by dt, and x4 is equal to dy2 by dt. And the applied force f of t is equal to u is the input. Okay. Now from this variables we are calculating x3 dash. x3 dash is nothing but d square y1 by dt square, and x4 dash is nothing but d square y2 by dt square. So now we are going to substitute these things in the differential equation. Okay. So instead of f of t you are substituting u, and instead of d square y2 by dt square, d square y1 by dt square, you are substituting x3 dot, and in the place of dy1 by dt you are substituting x3, and in the place of dy2 by dt you are substituting x4. So after substituting, you are calculating x3 dash. From this equation you are calculating x3 dash. Okay. Similarly, we are substituting the state variables in equation. In the second differential equation, you are obtaining like this. From this, we are calculating x4 dash. Then, so we have taken x1 is equal to y1. So dx1 by dt is nothing but dy1 by dt. What is dy1 by dt? dy1 by dt is nothing but x3. So dx1 by dt is nothing but x1 dot. Similarly, x2 is equal to y2. So dx2 by dt is equal to dy2 by dt. What is dy2 by dt? x4. So x2 dot is equal to x4. Now this is nothing but the state equations. So here you are having only x3. It can be written as 0x1 plus 0x2 plus x3 plus 0x4 plus 0u. Similarly, x2 dash, it can be written as 0x1 plus 0x2 plus 0x3 plus x4 plus 0u is equal to 0. Similarly, here you are having all the terms x3 dot, then x4 dot. Then we are going to write it in matrix form. So we are going to write it in matrix form. So in matrix form, we are writing like this. Okay. Now we are going to find the output equation. The output is y1 and y2. So y1 is equal to x1 and y2 is equal to x2. This y1 can be written as 0x1 plus 0x2. y2 can be written as 0x1 plus x2. So now we are going to write it in matrix form. So in y1 you are having only x1, so you are putting 1 in the place of x1 and 0 in the place of x2, x3 and x4. In y2 you are having 1 in the place of x2. Since you are having x2, you are writing 1 in the place of x2. In all other places you are putting 0. So now you have written the state equation out as well as output equation. Both these combine to form the state model. Okay, this state equation and the output equation, both of these combine to form state model. Okay.